Well, thank you very much for the introduction. It's wonderful to be here in Korea for this conference. I want to thank the conference organizers for highlighting the importance of creativity in society. It's great to be here also. We have a wonderful collaboration with Smilegate and the Smilegate Foundation. So I look forward to spending the next week here in Korea as part of our collaboration to help support and spread creative thinking here in Korea. I'd like to start my presentation today with a story. It's a story about a young member of our Scratch programming community. This member of the community goes by the username Ipsy. All the children in the Scratch community come up with a username, and the user Ipsy started on Scratch when she was about 13 years old. And in fact, before starting with Scratch, she really didn't have very much interest in computers. What she really enjoyed was drawing. She would go home after school every day and fill notebooks with sketches and drawings. That was the love of her life. But one day, a friend of hers suggested that she try Scratch. The friend explained that by using Scratch, Ipsy could make her drawings come alive. And that was interesting to Ipsy. So she tried Scratch, and this is one of her first projects. She took one of her drawings, and notice how the eyes and the ears are moving just a little bit, slightly animated. So this is a way for Ipsy to start experimenting with coding. This is the way that you code with Scratch, by snapping blocks together into a sequence. So Ipsy was able to put the blocks together to describe ways to move the eyes and the ears of her drawing. I see this as a great example of a way of learning something new. Oftentimes when we learn something new, we start with something that we're comfortable with, something we care about. Ipsy loved drawing, and she was comfortable with drawing. So then she was reaching out and trying a little bit of something new, testing out coding by adding a little bit to something she already knew and was excited about. Ipsy loved the idea that her drawings could come alive, so she kept making more Scratch projects to animate her drawings. A couple months later, she did the following project that was called Lemonade Time. It was a game where you could control a character to move through a scene. So Ipsy made this project and then shared it in the Scratch online community. In the project, users can hit the arrow keys to move the animal, the otter, to gather different ingredients for lemonade. You can ask for advice from other animals, the bird and the frog, to ask, where do I get sugar? Where do I get the lemons? As you walk through, you can gather the ingredients to make the lemonade. Ipsy shared this project in the online community, and thousands of other children in the Scratch online community tried out Ipsy's project, and they really loved Ipsy's project. This is the project page where she shared her project. You can see that 17,000 people viewed and tried out Ipsy's project. So there was a big audience trying out her project. Almost 2,000 people said they loved her project. 88 people remixed her project. What it means to remix is that they took Ipsy's project and they made changes to it. They made changes to the programming code or changes to the images. So it was a way that people could take Ipsy's work and build on it. And that's the way a lot of creativity happens. You start with something that someone else did, and then you add a little bit of your own to it. There are also many comments. There was 1,800 comments where people were giving suggestions and feedbacks and encouragement to Ipsy. And you can tell that Ipsy was paying attention to the comments, because if you look at the instructions, in the instructions it says, due to popular demand, the otter walks a little faster now. So people in the community had made suggestions that the animal should move faster. So like a good designer, Ipsy was listening to her audience and making changes. So Ipsy was really learning not just to how to draw and to animate, but also to be a member of a community, to take feedback and suggestions from others, and to continue to refine and adapt and change her work based on the suggestions from others. A lot of people looked at Ipsy's project and they loved her artwork. And they said, we'd love to see more of your artwork. Can you share more artwork? We would like to remix your artwork. We'd like to use your artwork in our projects. So Ipsy, based on those suggestions, started making projects where she just shared artwork for other people to use. Here's one of the projects. She even branded it Ipsy Studio, and then she had lots of different examples of artwork for others to use. And in the instructions, she explained, she said you can edit the artwork as much as you want, but make sure to give me credit. So Ipsy was learning to become a good member of a community. When you're a good member of an online community, you share things with other people in the community, but you also expect that other people will give you credit and acknowledgement. So that's part of what being a good citizen is in an online world. Digital citizenship means that when you borrow and build on other people's things, you give credit and acknowledgement. This was an important thing for Ipsy to learn. When people first started remixing her projects and using her artwork, at first she was upset. She said, they're stealing my artwork. But then we had discussions online, and we said, no, in an online community, if everybody shares, everybody benefits. So she changed the way that she thought about it. And instead of being upset when other people used her artwork, she became proud of when other people used her artwork, as long as they gave her credit. Ipsy was not just sharing her artwork, she also started to share some of the programming techniques that she learned. You might remember in the Lemonade Time game, the background moved back and forth. It's called a scrolling background. It's common in many games where the background scrolls. And that's not so easy to do in Scratch. In fact, I think we should try to make it easier, but it's not so easy right now. But Ipsy figured out how to do it, so she made a tutorial project showing other people how to make a scrolling background. So in here, she goes through, shows the scrolling background, and then gives advice on how you can make your own scrolling background. Here she explains it and shows the blocks, and then even goes and puts comments on the blocks. So again, Ipsy was sharing her knowledge with others. Now, when we created Scratch, we figured that we would make tutorials, and we thought that some teachers would make tutorials. We never imagined that so many kids like Ipsy would make tutorials. But if you go on the Scratch website, you'll find thousands and thousands of tutorials like this one, where kids are sharing their knowledge with one another. We see over and over that kids, when they learn things, they do want to share their ideas with others. And we think that everyone benefits from that. By Ipsy shared her ideas, it gave her a better understanding. As she communicated how she made scrolling backgrounds, she got a better understanding. And of course, other people using her project also were able to learn from Ipsy. So we're really excited to see children like Ipsy using Scratch in such a wide variety of creative ways. And we might think about, well, what is it that Ipsy was gaining as she worked on these projects? Now, a lot of people are interested these days in having children learn to code, to learn to program. And a lot of times they see it as an important stepping stone to a job as a professional programmer. So, now, to be honest, I really doubt that Ipsy will grow up to become a professional programmer, but that's not our main goal. In our goal, we see that Ipsy's gaining many other things. Of course, she is learning some specific technical skills, but it goes far beyond just the technical skills that she is learning. That as Ipsy worked on projects like these, we see that Ipsy is learning to reason systematically. As she puts the different code together, she's learning logical thinking and learning how to problem solve as new issues come up. But it's not just problem-solving skills and strategies she's learning. She's also learning how to think creatively, to come up with new ideas, to come up with different types of projects. You see in the great variety of projects that Ipsy created that she was coming up with lots of new ideas all the time. And that the ability to think and act creatively, I think, is more important today than ever before. That in today's world, things are changing so quickly. I think everyone agrees that society is changing more rapidly today than ever before. So today's children are going to face a never-ending stream of unknown and uncertain and unpredictable situations. So they need, more than anything else, to learn how to come up with creative solutions to the unknown situations that they undoubtedly will encounter in their lives. So that ability to think and act creatively is so important. And at the root of creativity is to create. So by creating projects like this, Ipsy is learning about the process of creativity. She's also learning how to work collaboratively. We can see it in many different ways in her project. She was collaborating in so many different ways. She was listening to the comments from other people and changing her projects. That's one form of collaboration. She was sharing her artwork with others, another form of collaboration. She was creating tutorials to share her knowledge, another type of collaboration. And I think we need to move in that direction. Too often when people have thought about programming, they think of the lone individual sitting at the computer. But the most creative work we know happens when people are working together with others, when they're learning with and from one another. I think sometimes people are too focused on an old-fashioned view of thinking and learning. It might have been influenced by the great sculpture, The Thinker by Rodin. You know, the thinker who sits like this. It's a single person sitting by himself in contemplation. And of course, we do some thinking that way, but I think the most creative work happens not just when we're sitting by ourselves in solitary contemplation, but when we're working with and learning from others, as we see Ipsy doing in these projects. Now, what is it that enabled Ipsy to gain these types of new abilities, to reason systematically, to think creatively, to work collaboratively? We really see these as important skills for everybody in today's society, regardless of what Ipsy grows up to be, whether she grows up to become a lawyer or a marketing manager or a journalist. These ideas of reasoning systematically and working collaboratively and thinking creatively will be important for everybody in society. So in our work, we think a lot about how can we support children to gain those new abilities. And as we've thought about it, we focused on 4 guiding principles about how we can support children developing as creative thinkers. And those 4 guiding principles all start with the letter P in English: projects, passion, peers, and play. So whenever we're developing new technologies or new activities or new spaces for learning, we always are thinking, how can we give children opportunities to actively engage in projects based on their passions, in collaboration with peers, in a playful spirit? And I think each of these is important. You can see with the way Ipsy was learning. She was learning coding by working on projects. Now that might seem obvious to us, but actually that's not the way many children today are introduced to coding. Oftentimes they're introduced to coding just by they're given a problem or a puzzle to solve. They solve it, they move on to a next problem. They solve it, move on to the next one. And when you're doing that, you certainly learn some of the core concepts of coding, but I don't think you necessarily develop as a creative thinker that way. We want children not just to solve problems that are given to them, but to come up with their own problems, to come up with their own goals. And that's what you do when you work on projects, as Ipsy was doing, of creating new ideas, having an idea, creating a project based on it, getting feedback from others, iteratively refining it. By working on projects is the way people understand the process of creative thinking. But of course, children will develop their creative thinking abilities only if they're working on projects that they really care about. If they're just given someone else's project, they might lose interest. So we've seen over and over that when people work on projects that they care about, that they're passionate about, they're willing to work longer and harder. They're willing to persist in the face of challenges and difficulties. And we saw that with Ipsy, that because she cared so much about her artwork and her animations, she was willing to work longer and harder because she was working on something she really cared about. So we want to make sure, as we created Scratch, if we'd made it that all you could do was to make one type of game, that would have been good for some kids, but not all kids. We want to connect with all kids' passions. Ipsy was interested in art. She was able to use Scratch to make her art come alive. If kids are interested in music, they could use Scratch to make their music come alive. If they're interested in science, they could do science simulations. So we want to build on people's interests is the best way to help them develop as creative thinkers. As we said before, the third P of peers, we want kids to work with one another. That by working with your peers is also a way that everyone can become more creative and the whole community can become creative. The way that Ipsy's ideas about scrolling backgrounds spread through the community. By working with peers, everyone in the community can become more creative and the whole community as a whole becomes creative. And the fourth P, play. I sometimes say that play is the most misunderstood P because sometimes when people think of play, all they think about is laughing and having fun. And of course, it's great to laugh and have fun, but to me, play is much more than just that. When I think of someone I think of play not just as an activity, but as an attitude, a way of engaging with the world. When you have a playful attitude, you're constantly experimenting and trying new things and testing the boundaries. And that's where creativity happens. Creativity happens when you're willing to take risks and to experiment. So it's very important when we develop Scratch, it's very important that the online community be a friendly and safe place. If people start experimenting and other people ridicule them or make fun of them when something goes wrong, they're not going to experiment anymore and they won't have any creative breakthroughs. So we need to make the environment a very safe environment where children feel comfortable experimenting, exploring, taking risks. For me, that's what I see as a playful approach. We sometimes talk about tinkering. In the earlier session here, Miles Berry was also highlighting the idea of tinkering, which I see is at the intersection between playing and making. So we want kids to have a chance to make things in a playful way, where they're having a chance to create things in the world and projects, but to continue to experiment, and that's the way they'll continue to learn new things. Now, these four guiding principles guided us as we were developing the Scratch programming language in the online community. And it's been very exciting to see more and more kids coming to the Scratch website from all around the world. There's a very active community here in South Korea. It's one of the most active places for using Scratch. And we've seen in recent years more and more kids starting to use Scratch. Last year, more than 8 million children joined as new members of the Scratch online community. Now there's more than 30 million kids around the world who have joined the community. Every single day, kids around the world create more than 200,000 new Scratch projects. So it's this very active environment where children are constantly creating things, sharing with one another. But more important than the numbers, in my mind, is the variety and the diversity of what children create. Because for me, that's the indicator of creativity. If there were 30 million projects on the Scratch website, but they all look pretty similar, then I wouldn't be so excited about it. For me, what's most exciting is the variety of projects. That we can see, if you look on the website, an incredible variety of different types of projects. You see everything from animated stories, to interactive birthday cards, to anime comic strips, to virtual construction kits. This was a boy in Belgium who made a virtual Lego construction kit in Scratch. We see recreations of classic video games. This is someone who made a recreation of Donkey Kong. We see new types of dress-up doll games. As I mentioned, we see tutorials that kids create. We see interactive artwork. We see science simulations. And for us, we judge the success of Scratch by this variety, by the variety on the website, or if we run a workshop, we always are looking to see what type of variety comes out of the workshop. If we have a workshop for 30 children and all the projects look alike, we feel that something went wrong with the workshop. We're going to be doing some workshops here in Korea over the next week, and that will be the way we judge them, is to see, do kids come up with a wide variety of different things? It doesn't always happen. Actually, when I was last here in South Korea, I told a story about one place where it didn't happen here, that one morning I woke up and I looked at the Scratch website, and I was surprised. I saw 30 identical projects. And I thought maybe something was wrong with the website, that it was accidentally, recreating all these projects identically. But I looked, and they're all done by a different child. They each had a different author. So I looked more closely, but they were identical projects, but done by 30 different children. And I realized that what had happened was, it must have been in a classroom where the teacher said, do this, do this, do this, now share your project. So they all did the identical project and shared it. And I looked, and I saw actually it was a classroom from here in South Korea. But we see other classrooms where there's great creativity. So it's not enough just to bring in the technology. The technology can be used in many different ways. As much as we've tried to have Scratch support creative use, people can still use it to just instruct people to do things one step after the other. So we need to have creative tools, but also creative teachers and creative environments to support kids in exploring and experimenting. We've been excited to see how Scratch is increasingly being used in schools. When Scratch first came out, it came out about 10 years ago in 2007. And at first it was used primarily in homes and in after-school centers like libraries and community centers. Schools were somewhat slow to adopt Scratch, partly because we didn't provide many materials in the beginning to support teachers, but also schools tend to be somewhat slow in adopting new things. But in the last few years, many schools around the world have started using Scratch. Sometimes it's used as a computer science course to learn computer science concepts, and it can be a good start for that. I must admit, I get most excited when Scratch gets used across the curriculum, and when schools use it as a type of tool to explore whatever it is that children are studying, whether it's in history class or science class or social studies or language. Let me show you a few examples. The first example is from a science class in India, where they were studying the layers of the Earth. And at the end of the class, rather than having students write a report, the students all made Scratch projects about what they had learned about the layers of the Earth. Here's one of the projects. So this student, he's giving a guided tour of the Earth. So again, he's speaking using his own voice. Maybe pull down the volume a little bit. So he's speaking in his native language of Kannada and explaining what he learned about what's happening. His teacher told us that this student was especially excited to learn that things are moving inside the Earth. So he's explaining things are moving inside the Earth. He thought the Earth was solid. He said, how are things moving inside? And he wanted to share that with others. So he was using Scratch as a way to explain what he has learned and then help other people learn about it. Here's another example from an elementary school in the United States where the children had read a popular book that's called Charlotte's Web. And instead of writing a book report, they used Scratch to do an animated book report. Here's one of the examples of this is a third grade child, about 9 years old, who told the story of Charlotte's Web. And of course, it was a language class, and you can see they were developing some language skills by writing about the story. But what interested me was that the child was learning many other things as well. Notice when the pig moves back, the pig gets smaller over time. So the student was learning something from art class about perspective. If you want to make something look further away, you need to make it smaller. So they were learning not just showing what they learned in language class, but also in art class. They're also learning important ideas from mathematics. To make the pig get smaller, in the Scratch project, what the student did was they multiplied the size of the pig by a fraction smaller than 1. Because if you multiply something by a fraction smaller than 1, it gets smaller. Now, usually in school, when students are taught about multiplying fractions, they don't know why they're being taught this. And a lot of them don't really pay attention or remember it. But here, the student was learning about multiplying fractions in a meaningful way. They could make use of it to accomplish something they really wanted to do. And I think that's the best way of learning things, to learn new things when you can put it to use in the context of work on a project. This is something I learned from my mentor, was Seymour Papert, who was one of the great pioneers of technology and learning. And Seymour would often say that schools too often said that students should learn the basics first and then they could put it to use. And Seymour said that's not the way of doing it, that they should learn, that it's important to learn the basics, but don't learn the basics and then use it. Learn the basics through using them. And that's what we see here. Children were learning important mathematical ideas through the use. So it wasn't understanding and then use, but understand through using. And that's what we always are trying to do with the technologies that we're developing. We continue to stretch Scratch in many different directions. There's a version of Scratch meant for younger children we call Scratch Junior. This is aimed for age 5 to 7. We typically think of Scratch for age 8 and up. So Scratch Junior, you notice the blocks have graphic icons rather than words, which is more appropriate for younger kids. And there's a simpler set of blocks specifically designed for storytelling. So Scratch Junior is a good way for kids to start to experiment with core computational strategies and ideas, and then they can continue to elaborate and expand on them as they move on to Scratch. We're also doing more and more of having Scratch not just control things on the screen, but to control things in the world. This is something we've done in collaboration with the Lego toy company. We've collaborated with the Lego company for many years to see how kids could build things in the world, but then use programming to make their physical creations come to life. And we really like this idea of kids both building in the world, but then building programs to control the things in the world. We really believe that kids learn a lot through the process of making and creating and building, so we want to give them more ways to make and create, both making in the physical world, but also making in the virtual world. Let me give you some examples of, as we were trying out prototypes of these types of ways for children to control things in the world, we've run a variety of workshops around the world. Here are a couple examples from a workshop we did in Hong Kong, where we had children build wearable devices. So we gave them some technology that they could program, that they could attach to their bodies. And we said, how could they make use of it? So here's one girl that attached it to her shoes and put a sensor on the shoes, so as she walked, it could detect her walking, and it turned the lights to different colors. Those little balls could turn in different colors with lights inside. I really like this example because she was inspired by something she had seen in the everyday world. Many children's shoes these days have lights that will light up, but children don't get to control it. Somebody at the shoe company decided how to program it. We want to give children control over that. So she was grabbing control, inspired by what she saw in the world, but that she wanted control over, if I do a certain type of walk, I want the lights to turn a certain color or to have a certain type of pattern. At the same workshop, a boy made a wearable jukebox. So it had a sensor that when you put in a coin, it could tell what type of coin it was, and then it would play different music. So he was imagining he was a budding entrepreneur, and he figured that he could wear this jukebox, people would put money in, and then it would play music for them. So we can see how if you give kids the right types of technology and support, it can unleash incredible creativity. I'll show examples from another workshop we did halfway around the world in Iceland. And in this workshop, we asked kids to make different projects that they could do things for their home, to automate the home. So one girl at the workshop made a security system for her room that had a light and a light sensor. And if someone tried to enter her room, it would sound an alarm to scare them off. But one of my favorite projects from the workshop was this alarm clock. And it was a light-triggered alarm clock. They had a light sensor, and when the light would come in the window, it would trigger the sensor, that would turn on a motor to ruffle his hair, and also start playing music to wake him up. And I thought this was very clever, but actually at the workshop, someone pointed out a problem with this. Because as you know, Iceland is very far north. So, in the summertime, the days are very long, and in the wintertime, the days are very short. So someone said to him, is this alarm clock going to work very well? Because the sun usually doesn't come in the window right when you want to wake up. So he thought about it, and at the final presentation, when he was showing his project, every student had a poster describing their invention. And in his poster, he explained how his invention, the alarm clock, was working. And at the bottom, he had in big letters, it said, for export only. So again, this is an example. He was learning to listen to advice from others and thinking about his audience and recognizing who it is that might be able to make use of his inventions. We want to continue to support this type of expansion of what kids can control with Scratch. I think we see Scratch not just as a programming language, but a type of platform that kids should be able to use to control anything that they want to control. So whenever anybody wants to program anything in their lives, there should be a common language that they can use to control everything that they can imagine. And that's what led us to develop a next generation of Scratch. We're working on this next generation called Scratch 3.0. There's a prototype version out now, but it's going to be officially released in January, the beginning of next year. And we're really excited about this new version. Like all the previous versions of Scratch, it will be free. So the software and the online community will all be free for children around the world to use. But it will expand the type of things that children can do with it. This is a screenshot from the new generation of Scratch, from Scratch 3.0. One of the important new features of Scratch 3.0 is it was built in a more modular way, so we can keep on adding new type of capabilities to it. And not just we can add new capabilities, but other people could add new capabilities. So if some company in South Korea or in Italy or in Brazil makes a new robotics kit, they can make a new collection of Scratch blocks to control their creations. So we call these extensions. Each extension is a new collection of blocks to control something, either control something online or to control something in the world. Let me just show a couple examples of the types of things that these extensions could do. Here's an example of a software extension. So this is for doing speech recognition and speech synthesis. And we think this is important because growing up in today's world, children are becoming accustomed to being able to talk to devices and they respond. With things like Siri and Alexa, children will talk to devices and things will happen. But too often it just seems magical. We want children to have the power to make their own projects respond to voice commands. So we're going to do an extension that connects to speech synthesis and speech recognition software. So this is our new AI technology we're putting together into Scratch blocks to make it easy for kids to use. So I have blocks that say like speak and then a word, and it can generate a voice. Or a block that says, when I hear a certain word or a phrase, then something should happen. So you could trigger Scratch projects based on a voice command. Let me show, this is actually just a simulation of how it might work. So in this project, it says, when I hear, what time is it? So the key word is to say, what time is it? And then it will speak, it will say, it's party time, and will launch an animation. So if I say the words, what time is it?
Party time.
So again, this is a way for kids to be able to take things they see in the world and use it at their command. I'll show one more example that's connected to the physical world. As many of you know, one very popular new type of technology is called the microbit. This has become popular in many parts of the world. It's a low-cost microcontroller that you can use to have, it has sensory capabilities. You can send sensors back to the computers. It has some display on it. So we're making a way to connect Scratch to the microbit to make it easy for kids to take the microbit, build it into physical devices, and then use that to control a Scratch project. So for example, kids could make a Scratch game and then make a physical controller. So actually, we're going to try to make this work. I'm not sure it's going to work. We were trying to do it on stage, and that didn't work. So here we have this project. This is a Scratch project that was made. It has a flying bicycle, and then someone made bicycle handlebars out of this simple piece of foam. And the idea is I should be able to control the bicycle on the screen with these handlebars. So I'm going to give it a try now. And there, yeah, it's working. So I'm trying to intercept the balloons. Oh, a taco. Get extra points for tacos. So I think that gives you a sense of the type of things. Now again, kids grow up in a world where they have all types of ways they can control their games remotely or by gestures. But again, we want kids to be the creators. Create the games, create the controllers. So doing it with the microbit and other technologies, we're going to open up for kids to be makers in the physical world, also makers in the online world. So we're really excited to see what kids will be doing. Actually, here in Korea, on Sunday and Monday, we're running workshops with the Smilegate Foundation to try out this technology. It's still in a prototype form, but in January, this will be released for all kids to be able to use it. And in many countries, the school systems are getting microbits for all the kids. We hope that they'll then use Scratch to be able to use have an easier way to use the microbit for creating their own games and stories and animations. Now, if we go back to the slides. So, even as we add new technologies, we always have to remember that I think what's most important for us is not the technologies themselves, but the ideas underlying them. With each new technology we develop, whether it's with speech recognition or a microbit, we're always thinking, how can we support kids creating projects based on their passions, in collaboration with peers, in a playful spirit? I think our ultimate goal is for kids to feel a type of fluency with new technology. And what do we mean by fluency? When you become fluent with language, it doesn't mean you can just read a street sign. When you're fluent with language, it means you can tell stories to other people. And we want children to feel the same way about technology they do with language. In schools, we don't teach kids just to read. We also teach them to write, because we want kids to have a voice, to express their ideas. And unfortunately, too often when technology gets introduced, it's almost as if all kids are doing are interacting with it. We want to make sure they're also creating with it, the equivalent of writing. So we think that the same way that when you learn to write, it helps you learn many other things. When you learn to write, it helps you learn to organize and express and share your ideas. We see coding the same way. Coding is not just some technical skills. We see coding as a new way for kids to organize and express and share their ideas. They can create new types of things. Rather than just using words in a story, they can make dynamic, interactive stories and games and animations. And our goal is not just for kids to develop new thinking strategies, although that's important, but also to develop their voice so that they can express their ideas in the world, and also to change the way they think about themselves. I think in the great literacy movements of the world, a main motivation of the great literacy movement that Paulo Freire led in Brazil, it was not just about teaching people to read and write so they could get jobs, although that was important. He said to be a full member of society, you need to be able to express your ideas through writing. I think as we look ahead, if we want children to grow up to become full and active participants in tomorrow's society, they need to be able to create and express their ideas through new technology. And we think that's the way we should be thinking about coding, as a way to let everybody grow up to become a full and active participant and contributor to a society that will require creative thinking more than ever before. I think in today's world, the ability to think and act creatively is going to be the thing that is the key to success, and I think the key to happiness. When you learn to create, it won't just open up new job opportunities, but I think it's also the key to joy and meaning and satisfaction in life. So it's not just an economic imperative, but if we want our children to grow up to lead full and joyful and meaningful lives, giving them the opportunity to create with technology, to express themselves, is the key. this is a big task to try to spread these ideas around the world. Hopefully, our Scratch software is reaching millions of kids as a start, but we also have to spread the ideas. And I think that's where I think we need help from everybody. We need partners all around the world to spread the ideas of the importance of not just using technology, but using it to design, create, experiment, and explore. One way that we do that, we do it by coming around and talking to conferences like this. We also have online courses. We have a course called Learning Creative Learning. It's a way you can learn about creative learning. In fact, this week we're starting a new round of the course. If you want to check it out, you can go to the URL at the bottom, lcl.media.mit.edu. LCL for Learning Creative Learning. So it's a way to, it's a way for everybody to start learning more about how to support creative learning and cultivate creative learning. And there are many language-based sub-communities within learning creative learning. So no matter what language you speak, you'll find other people there you can share ideas with. Also, I'm really excited to be here in Korea this week for the launch of my book, Lifelong Kindergarten. And this book is a way to also that I've been trying to share the ideas, not just the technology, but the ideas of cultivating creativity through projects, passion, peers, and play. So I really appreciate, again, the help of the SW교육 Foundation and the publishing company that bring out the book. I really hope this is a way that can help share the ideas. But again, there's a big task more than any one person or any one group could do. So I hope that you'll join me in this effort. I think there's nothing more important than helping today's children grow up as creative thinkers so they can be full and active participants. I hope you'll join me so that we can really open up new opportunities to open new possibilities for today's children and tomorrow's society. Thank you very much.